Alright, we're going to pick up with the example that we started last class. And what we're looking at here are properties of quadratic functions in standard form. And we had mentioned last class that there were three forms of quadratics we were going to look at. Standard was the first one. And you have a standard form equation when it's written in this form. X squared, when you have an x squared term, you may or may not have an x, and you may or may not have a constant number. The constant number is always the number without an x term. Alright. Okay. First step usually suggests that you write out your a, b, and c terms. So remember that with a standard form, it's written, as we just said, ax squared plus bx plus c. So the a term for this equation is 1, it's 1x squared. B term is -8. And your c term is 6. First question you're asked is direction of opening. Because the a value is positive, the direction of opening is up. Because a is positive. So we know the graph will do this. Because the graph points up, a maximum and minimum point, it would have a minimum point. And the minimum refers to the y value. So that here, the graph would have a lowest point. Width of the graph, the a value is 1, so the width of the graph is normal. And the reason for that, the a value is equal to 1. The vertex is where you would find the middle of the graph, where the bend is, or curve. And we had said last class that any point on a graph is always written as an ordered pair, x value, y value. To get the x value, there's a formula you need to remember. (b over 2a. So the (b), well, the negative sign always goes there. That's going to be a fraction. Our b value is -8. So we'll put the -8 in brackets here. Over 2 times, and our a value is 1. This will give you 8. Negative times negative is a positive. 2 times 1. So you get a value of 4. That's only 1/2. So right now we have a value of 4. So I'm going to just move down below and we'll figure out what the y value of the vertex is going to be. So for the y value, we take our equation, and it's written x squared minus 8x plus 6. And what you do here, you substitute in the x value. So we put in the x value of the vertex. So this came from the vertex, what we just figured out. So when you figure out the x value for the vertex, you put it back into the equation. And that's sometimes written this way. I'll explain that in a second. So everywhere we see an x, we put a 4. Instead of writing just y equals, we're going to write this as y bracket 4. And what that means is that we're going to find our y value when the x value is 4. So the y value when the x value is 4. Then you work out the math. 4 squared is 16. 32 plus 6. Now you have 16 take away 32 plus 6. And that'll come back and give you negative 10. So for our vertex, we have that here. So we have the x value and the y value. The axis symmetry, I'll talk about that when we do the graph. However, it's always the x value of the vertex. So I can just write that in now. But I'll explain it more when we graph it. The y-intercept is where the graph will cut through the y-axis. And it's always the c value. So the y-intercept will be written as 0, 6, and again I'll refer back to that when we do the graph. The max or min value, well, we just said it was a minimum, but its actual value, is negative 10. Let me just get the eraser there, guys. Sorry about that. So, let me just do that here. Domain and range, I'll talk about those now as we plot it. So we'll come back to that. Alright, so let's take our information here and graph it. So we know we should have a graph that points up. Where we'll start is at the vertex. It is over at 4 and down at negative 10. So on your graph, count over 4 spaces, go down 10, and it will be here. And we're going to label this point. It's 4, negative 10, and this is our vertex. So when we graph, we'll start first with the vertex, then we're going to put in the y-intercept. So that's where the graph cuts through the y-axis. So the vertical line here, and we're told it cuts through at 6. So our graph will curve down, meet the vertex, and curve back up. It would be hard to graph it just through 2 points. We need at least 3. And this is how you're going to get your next point. The graph has a middle, it's symmetric. And that will be right down through here. We said the... Sorry, let me move that over. Let me do that right. We said our axis of symmetry was at 4. Anybody can show you how to do it wrong. So let me show you how to do it right. And I'm going to put that in as a dashed line. If the graph is symmetric, you would go from your axis of symmetry, and it's 4 points over, and you're at a height of 6 here. So it would make sense then if you went 4 points on the other side, and you would have another point on the graph. Then if we do the best we can here now to draw on as smooth a curve as possible, graph would come up here. And we always put arrowheads on our graph. There. What we don't know, and we'll learn this later, is where the graph cuts through the x-axis. So don't worry about that, having these points here, but you'll learn that later. So let's go over what we have. We have a graph that points up. It has a minimum value, which is here. We have a graph of regular width. We found the vertex. Now this axis symmetry, so we spoke about this in class, that when you have these quadratic functions, they're symmetrical. So there's always a middle line that could divide and split the graph in half. This middle line is always at the x value of the vertex. So when you're at the vertex, do a dashed line going up or down depending on your graph, and this is the line that splits the graph in half. So what we're saying is that the left side of the graph should be the same as the right side. Because of that, when we use our y-intercept, so from our y-intercept is 4 spaces from the axis symmetry on the left, so there should also be a point on the graph 4 spaces on the other side. So this point should be, well, if we count them, 4 and 4, that will be 8, and at a height of 6. And this is the x value here for the y-intercept is always 0. So that's why I wrote it as 0 here. Because for y-intercept, the x value always has to be 0. Anywhere up and down the y-axis, the x value is always 0. Domain refers to possible x values. So you learned that last year, and in case you've forgotten, domain always refers to values of x. Range always refers to values of y. And when you think about the x values going across the number line here, there's nowhere you couldn't put your finger here across on this number line that you couldn't rise up or down and strike the graph. So let me just show you that here. I'll use a different color. So if I said I want to go here at x value of 2, and I put my finger down, hey, I'd strike the graph. If I go at a value of 1.5 here, and I put my finger down, I would hit the graph. You'd always have a place where you would hit the graph. If this graph goes forever up, it's also moving over. So even if you went over -10, and if our grid were long enough, and we could go up and up and up, we would find we would touch the graph. And the same anywhere across the x-axis. So the x values could be anything. And how we say that is when your x values could be anything, x belongs to the real numbers. The curve, this is a Greek letter, a Greek symbol, and it means belongs to. So this symbol here means belongs to. So x belongs to, or it could be any number. So when we say real numbers, it refers to decimal numbers, negatives, positives, could be anything. Now let's look at our y values. It doesn't work quite the same here. Your y values have a lowest point. So if you're looking down the y-axis, what is the lowest you ever go on this graph? Well, it would have to be here at -10. The graph doesn't exist below -10. So all your y values are from -10 and above. So your y values are always bigger than or equal to -10. We need to add in one more thing. We also have to state, well, what kind of numbers can they be? Are you going -10, -9, like steps, or could you have decimal values? And you could have any number, so the y values belong to real numbers. And there's one value here I said I was going to come back to, and that's the minimum value itself. Well, it's -10. That's the lowest value you have on graph. So the max or min value only ever refers to values of y, and you get that from your vertex. So your vertex is one of the important things to get right in your graph, because it's going to give you, well, first, the bend in your graph. It's going to give you your axis of symmetry, which you then need to get all of your values to graph from. Without the axis of symmetry, we wouldn't have been able to get this point. And your vertex is also going to help you get the max or min value. So these values here get used a couple times. So it's important to get this right. Okay. I'll take these notes and I'll also post them to the course site, but the answer keys are there anyway. What I would like to do is pause the video, and in about 5 minutes you should be able to do this part. So I want you to pause the video, and when you come back I'll take you through how to do this. Alright, assume you paused it. I suggested last time you write out your values of A, B, and C. Well, I can do that over here. So the A value is -2. The B value is 4. And the C value is -1. What I want you to understand, it's not always the first, like, it doesn't always go A, B, C. If I took this same equation and I just rearranged the numbers. So I had 4x minus 2x squared minus 1. It's the same equation. Same numbers are there. The B value is still 4. The A value is -2. And the C value is here. So A is always in front of the x squared. B is in front of x. C is just a plain number. So don't get caught in the thinking it always has to be A, B, C. Exactly as it's written there. You may have to rearrange the equation. Okay, the direction of opening is down because the A value is negative. And you don't need to put the reason in there. I'm just putting it here because I'm going through it with you. So A is negative, so the graph points down. Because the graph points down, and I'll erase this in a second, the graph is going to do something like that, point down. Then it has to have a maximum point. It's got to have a highest. What we're going to find out in a little bit when we get our vertex is what is that maximum value. The width of the graph. The A value, when you're doing this now, ignore the fact that it's negative. But just the number itself that's there. The A value is bigger than 1. And we looked at last class what happens when the A value is bigger than 1. And either it becomes narrow or wider. And this one, when A is bigger than 1, if you remember from last class, it becomes more narrower. Now, narrower suggests you're comparing it to something, so it's narrower than the regular graph, where A equals 1. You want an example of that, look back to the last one. Okay, so here now for the vertex, you need X value and a Y value. Now, I'm not going to work that out in that space. So I'm going to write the equation here. And we're going to work that out. So for the vertex, you get the x value first, and you get that through the equation, -b over 2a. So you put then the negative value as a fraction. So you can always fill that in first, negative and fraction line. B value is 4. The A value, so the equation is 2 times, and A we have -2. So you end up with -4 over -4, which is 1. So out of our vertex, we know one value, and it's 1. Now if you wanted, you could jump ahead and go, well, if I know what the x value of the vertex is, I then know the axis of symmetry is at 1. So there's always things you could graph, even if you thought you couldn't do the whole equation. Well, I could put in my axis symmetry. So the x value of 1 will be here. And I said put in a dotted line or dashed line. All vertical lines are written as x equals 1, because up and down this entire line the x value never changes, so it's x equals 1. So remember, I said a couple minutes ago the vertex is really important. Alright, let's get the y value of the vertex. So let's get the y value when we're using an x value of 1. So -2. So don't write x squared anymore. I got a value to put in for x. So whenever we had an x, we replace it with 1. 1 squared is 1. So -2 times 1 is -2. 4 times 1 is 4. Take away 1. So you get 2. Take away 1. 1. So our vertex is at 1, 1. So go over 1 and up 1 right here. So this is our vertex at 1, 1. And let's write that in here. We then need to get the y-intercept, and we said that's always the plain old number. The number that doesn't have anything added onto it, and that is -1. So the y-intercept is at 0, -1. And that will be right here. Let's use red for that again. Now say you need to have a third point. 1, 2, to get your third one, start at your y-intercept. How far away is that from your axis symmetry? It's 1 space away. Then we're going to go 1 space on the other side. And just, let's put in the values of that, because we should know it. So we would go over 1, 2 spaces. And what do you know? The y value doesn't change. The height of that doesn't change. Anything else we need to graph it? No, we just go ahead and connect our points. So the graph would come up, come down, and would look something like this. That is an arrow. Okay. Things we should finish off here. We know the graph has a maximum value. If we look at our graph here, it does not get any higher than this point right here. Right there. Now what is the y value of that? 1. Graph does not exist up here anywhere. The graph goes from a maximum height of 1 and then forever down, 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 forever. Domain, well, the graph is going to move forever down, and as it moves down, it's going to move forever over. So you could have any value here. And the same on the other side. So what you're going to find for 99% of these graphs that you're going to do, the domain is always going to be the same. You could, if you remember this, that's normally always going to be there. It's not going to change from that. The range, let's look at your y values. Well, if this is your maximum height, the y values only get smaller from that. So the y values are always less than or equal to 1. But you could have any number. I mean, if you went down here and said, well, would I have a y value of negative 5.5? Yeah, because the graph would go down and you'd have that value. The graph would continue down on either side and you'd find that you'd still hit the graph. So what you look for the ranges. Could I put my finger anywhere on the x or y axis, move it up or down, and still hit the graph? Alright. And I'm going to fix this one, and I want you guys and folks to do that. Okay, so let's take this one here now. Write our A, B, and C values. A value is a half. B value is 2. C value is negative 4. And if you figured it out right now, well, we said the C value is always the y-intercept, so you know over here at negative 4, you're going to cut through. Now, I may need to move this left or right, but I'm just going to say 0, negative 4. That's going to be our y-intercept. So here, 0, negative 4. So you know that. Direction of opening. The A value is positive, so the graph will point up. If it goes up, well, then it must have a lowest point. It bottoms out. Bottoming out would be a minimum. The width of the graph. Well, the A value is a half, so A is less than 1. So that means it's wider. And remember, wider than A equals 1. Vertex, well, that's where we got to do that little short equation. So we want the x and y value. The x value is always gotten through negative b over 2a. And I said you could always start by doing this. Put your negative sign and the fraction. B value is 2. A value is a half. So 2 times a half. Oh my goodness, fraction. Alright. Negative 2. 2 times a half. Well, this is not as ugly as it would appear. 2 halves will be 1. Now if you want the math way, here, 2 cancels with 2, leaving you with 1. Or, if you really got to work it out, 2 times a half on your calculator. I hope you don't have to work it out. So we get our x value. Now we need to get our y value. So we need the y value when the x value is negative 2. So we have a half x squared. Well, hey, this is a little test for you. Take the a, b, c values and come back with the equation. Well, a is a half. Half x squared. B is 2. So 2x. And c is negative 4. Now we don't need to leave it as x squared or as x, because you have values to put in there. Don't forget square. I'm just taking it out of the way right now. Negative 2 squared and negative 2. Half. Negative 2 squared is 4. Do not put negative 4 there. When you square a negative, you always come back with a positive. 2 times negative 2 is negative 4. Subtract 4. working this out, you're multiplying, so you're allowed to cancel. 2 goes into itself once, and 2 goes into 4 twice. 1 times 2 is 2. Take away 4 and take away 4. So negative 2 take away negative 4. That comes back. This is negative 2. Take away 4 more. Negative 6. So you got your vertex here. Negative 2 and negative 6. And we have the axis symmetry now because it's always the x value of the vertex. So if you went over at negative 2, here's negative 1, negative 2 is here. What else do we know? The graph has a minimum, so we know what the minimum value is. And let's just put our vertex there, and you can see the minimum value should be negative 6. So over 2, down 6. This is your vertex. And put these points in there, please. That would really help. Well, it helps you more, because you get full marks when you ask to graph it. Alright, remember we said 3 points, right? 1, 2, third one. We look at our y-intercept. It is 2 spaces away from the axis symmetry. So go 2 spaces on the other side. And we're even going to give that a value. And it's going to be over negative 4, down negative 4. So our lowest value is here at y equals negative 6. So I'm going to switch color because I don't want it to blend in. So here and up, and this is your graph. There you are. Now, domain, this graph will forever keep going up on either side. So, no matter where you put your pencil on the x-axis, so you could say you're going to put your pencil right here. Right there, sir. At some decimal value. Would I go up and reach the graph? Yes, you would. Let's go over here and go up. Hey, you still hit the graph. So there's no limit on what you can have for the x values. The x values belong to the real numbers. They could be any number. So the range, well, if you put your pencil anywhere on the y-axis and you decide to stop right here, and you go left to right, you don't hit the graph. That's why there's a minimum value here, right there. So the y values are all bigger than negative 6. And the y values belong to the real numbers. So this vertex has got a lot of useful functions. So if we just look at the x value of the vertex. You got it there, and you use it in the axis symmetry. And you also need it from the y value. Calculations down there. If you look at the y value of the vertex, So that gave you your, it's either going to be a max or min value, but it gives you that value, and it gives you your range. Now you got to look at the graph to know if it's less than or equal to or whatever. And I did leave one thing out for anyone who noticed it. Equal to. Okay, that's it, folks. That's graphing. So give you a couple more examples that will work out, just to make sure you got it done. And any questions, you can let me know next class.